And looking at it here, we can see that it's a dictionary with a messages key, and it's comprised of all the messages sent to and generated by the graph. In our case, we have a human message, right? Here's the content of a human message, which contains our prompt. And in here somewhere, there's also an AI message. I don't know if I want to bother actually finding it or not, because as a convenience, LangGraph messages have a pretty print method. So let's just go ahead and loop, right? We have our agent state, which has its messages key. We're going to loop over the messages key of our agent state. And for each of the messages, we're going to use its pretty print method, which is a convenience. And you can see here are all the messages that were contained in the state of our graph, namely our human message, give a short summary of a directed cyclical graphs in the context of computer science. And then here's our AI message, which is the model response. Right? Okay, so now that we know how to send a prompt and get a response from our agent, which is slightly different than how we used our LLM instances directly, let's look now at invoking the agent to use a tool. So this time we're going to do the same thing, capture the agent state by invoking it and passing in a prompt at the messages key, but we're going to send it a prompt where we would assume the multiply tool will be used. So once again, we will invoke our agent and capture the agent state. And as we did earlier, we will loop over the messages of the agent state. And here we can see the initial human message. But now, as we might expect from what you learned in the previous notebook on tool calling, rather than the AI message returning a response, it instead indicates the need for a tool call. Right here we have the tool calls field. You can see it's indicating that the multiply tool ought to be called. There's some additional data here about that tool, which we can ignore for now. And it specifies that the args that ought to be provided to the multiply tool, which it has, let's say, extracted from the incoming prompt, are 19,944 and 2,324. And then we have a new kind of message, which we haven't seen before, called a tool message. And this, in fact, is the message from, if I come up here, this tools node, right? It's sending a tool message back to the agent. And this is coming from the multiply tool, and it's sending the result of calling the tool. And now we have a final AI message that states the product of 19,944 and 2,342 is this number, right? So here we're observing how agents, are really unlocking and facilitating the capabilities of tool creation, because the agent itself is able to reason about when the tool ought to be used. It's able to actually invoke the tool. And then, unlike what we were able to do in a previous notebook, is actually able to construct a meaningful response back to the user that's incorporating the result of the tool use. Okay, so let's try one more prompt, but this time we're going to use a prompt that requires the multiply tool to be used more than once. So we're asking, what is the value of this? And also, what is the value of this? If we loop through the agent state after the invocation, you can see that we have the initial human message that we sent in, and now we have an AI message indicating a tool call to multiply 19,944 by 2,342. We have a tool message back from the multiply tool with the result of that. But now our React agent node is able to understand that there's a need for a second tool call, which it is able to articulate here. And we get back a second response from the multiply tool. And now finally, that all necessary tool calls have been made, we have a final AI message, which has a response of that incorporates the answer of both of the tool calls, which is quite powerful. Okay, so just briefly, let's take a look at some issues that you might have when you start working with agents like this. and specifically talk about how we can use techniques from earlier in the workshop to facilitate the use of agents. So just as an experiment, let's send another message into our agent where we would expect the agent, where we would not expect the agent to use the multiply function. So we're asking in what year was NVIDIA founded? The actual answer is 1993. And if we look here, you can see for some reason, the tool or the agent thought that the multiply tool ought to be used to answer this question. And it's not entirely clear why, but it seems like a reasonable hypothesis maybe that because the answer to the question was an integer, the agent thought that it ought to use the tool. And even worse, the agent, the LLM hallucinated two integers, 1958 and 1, to pass into the LLM tool, neither of which were the actual integer value for the year when NVIDIA was founded, which again is 93, and then use the result of this mistaken multiplication in its response. Okay, so this is a problem. This is a problem, and we can see what happened, although it's not quite clear why. Okay, so let's do some prompt engineering that we already know how to do with a slight modification in the context of agents to help address this problem. So let's be more specific in our prompt in hopes of getting the LLM agent to behave as we would like. If we wanted, we could try being more specific about when the agent ought to be using its tools by writing a longer, more specific prompt, right? We could create a prompt template and then just feed the final prompt as a parameter into the prompt template. You know a lot of different approaches to do this. We're going to pick one here, which is to create a system message that also utilizes zero-shot chain of thought prompting. And the system message states you're a helpful assistant capable of tool calling when helpful, necessary, and appropriate. Think hard about whether or not you need to call a tool based on your tool's description and use them, but only when appropriate. Whether or not you need to call a tool, address the user's query in a helpful, informative way. Okay, so we know that system messages are powerful, have heavy influence. So the question now is, how do we provide this system message to our agent? Well, it turns out in the case of the pre-built agent we're using, we can add a system message when we instantiate it using the state modifier named argument. If you want, you can take a look at the create React agent doc string. You don't need to read the whole thing, but just to prove about the existence of the state modifier. Yeah. So with that in mind, we'll recreate our agent using create React agent. We'll pass it our LLM, we'll pass it our tools, but now we'll also pass it our system message. If we invoke it again, in what year was NVIDIA founded? We can see that our system message has sufficiently impacted the agent to not make the tool use that we wanted or that we didn't want. And we got back the correct answer, which is 93. And just as a good practice, since we've made significant updates to our prompt in a way that impacts how and when it calls tools, let's make sure that the agent is still invoking the multiply tool as we would wish when it's given a multiplication program. So yeah, given this here, it looks like it was successfully able to utilize the tool just as we would hope. Okay, so as it stands, we have the ability to invoke our React agent and observe all the messages in its final state. Let's go one step further and construct a chain to make invoking the agent more straightforward and also make it easier to observe only the final response that we get back from the agent, potentially after the agent has utilized any tools. So we'll start by simplifying passing in an agent prompt. To do this, we'll create a runnable lambda called convert to agent state. It simply takes our prompt and returns, instead of the bare prompt, a dictionary where prompt has been included in the list at the messages key, as we know the React agent expects. And we can invoke this with a string prompt just to confirm that it returns the value we would expect. And this, as you remember, is what we actually need to send to the agent. We can now create a chain using our convert to agent state that we ought to be able to pass a simple prompt. And you can see this is working as expected. As a final step, let's create another runnable lambda, this time so that we can get just the final agent state. If we look at the structure of agent state, we know that it is at its messages key, it has a list of messages. So what we're going to do is we're going to take the final agent state, we're going to access its messages property, we're going to get its last value and pop the content field off of there. We're wrapping this functionality in a runnable Lambda so we can include it in our chain. And now we have another chain where we again are using convert to agent state, the agent itself, but now we're going to include this agent state parser we just created, so that now when we invoke it with a simple prompt, we get back just the response. And furthermore, even if we need to utilize tool use, you can see that we get just back the response, and it would appear that, at least in the case of this multiplication tool, that it's working as expected, which is super handy. Okay, so definitely some new information for you there. It's kind of just the start of using agents, but hopefully it makes sense. Hopefully you feel like you could construct and leverage one of these. And with that in mind, we're going to give you an exercise. We would call this also one of the projects of the workshop, where you're going to create an agent that's capable of using a third-party API to understand the air quality of a given location. So yeah, for this exercise, you're going to create an agent that's capable of using an external API to fetch real-time air quality information for a given location. To assist your work, we've provided the following function that, given latitude and longitude coordinates, will return the current air quality as a categorical string for that location. You don't need to concern yourself too much with the inner workings of this function. Just know that it uses a free open source weather API called OpenMeteo to fetch results, and then converts the numerical results retrieved from the API into a categorical string like good, fair, poor, etc. Okay, so we have this function is expecting, as the API expects, latitude and longitude values, which are floating point values. But it's worth mentioning that the LLM we're using today is quite capable, without any external tool use, of converting a string location into a longitude and latitude coordinate set. So we don't need an additional tool to convert the location name provided in a prompt, like a city name, like Dallas, for example. We don't need to actually do anything explicit to convert that into latitude and longitude, right? The model knows how to do that. So just to prove the point, let's take our LLM. Again, this is not an agent, it's just our LLM instance. And we're going to invoke, give me the latitude and longitude coordinates for Mumbai, India as floating point numbers. And you can see it kind of gave us two different versions of it, but ultimately the floating point numbers, and you can see it's up for this task, right? So